And so I know there's going to be people like, if they can't stop it, I'm not even going to try. But that also does not fix the problem or protect anybody. It just
my
gives
neighbor
the bad
got
guys
broken
more
too,
time.
so I just leave my door unlocked.
I know.
You're listening to the Help Me with HIPAA podcast, where HIPAA and humor collide to make learning fun. Your delightful hosts are Donna Grindle and David Sims. Relax. HIPAA help is on the way.
Welcome to the Help Me with HIPAA podcast. My name is David Sims of HIPAA for MSPs, and joining me today, as always, Donna Grindle of Cardin Compliance. How's it going, Donna?
It's going well. I don't know if I'm ready to keep up with you. You're talking really fast today. We do have a lot to cover, but I don't know that we can do it that way.
Oh, man. So, well, it's like I tell people sometimes, listen fast. I'm going to talk fast. Oh, man. I tell you, it seems like it never fails that when you think you've got some kind of downtime where you can kind of focus on some things, man, just stuff goes haywire. And we see that a lot with the people that we deal with. But you threw something at us this week that's, oh man, we're going to go down a rabbit hole today.
I know. But I went down a rabbit hole and I felt like everyone else should go with me.
So follow me, Alice. We're going to be going places. But today we're going to talk about medical device security, which, for somebody on the outside, you almost kind of want to go, what? Yeah. Medical device security? But, most people don't realize that those things are computers. And as such, they need to be protected. They also have vulnerabilities. And many of them even run off of the same software operating systems that PCs run off of. So they technically are a PC. However, there's not a lot of attention paid to them when it comes to security. So we will find that out today in detail.
Yeah, it's scary. I was like, I'm going to have to become way more paranoid in our analysis about every little device. What has that got on it?
Yeah.
I'm already paranoid enough. It's a warning to all my clients. I'm becoming more paranoid.
They make medications for that.
I know, really. But the important thing, though, is not just that it's a device and you may not know what's the device on it. The software running on the device may have. In other cases, there's a workstation that controls the device, and that workstation is running Windows XP
or earlier.
But first, let's talk about why we should really worry about. There's a real threat to the patients, and then there's a threat to the network because these devices are used as gateways to get into stuff. But there's also what happens to patients if these devices can be messed with. And I remember when this happened, and as far as I know, I don't know that it's ever been corrected. And it goes back to 2001, which, tells us another thing, that they're really paying attention. The Medtronic insulin pump, there was a cybersecurity researcher, and he did a demonstration on stage where he took remote control of an insulin pump. So imagine that you are someone that's diabetic and needs one of these things, and somebody can cut it off or add way too much.
It's kind of scary.
And then they had just a recent one where another security expert showed that medication pumps. So I know you've had surgery like I have, where you're so happy to find that little button when you come to. You're like, oh yeah, patient controlled anesthesia. But
more pain, meds, more pain.
Right after surgery, sometimes they just need to sleep. But they were actually able, and because the report said it was 300 feet away, that tells me there's Bluetooth involved. I would assume, wouldn't you?
Yeah, I don't know. That's still
300 feet.
No, that's probably too far for Bluetooth.
I don't know. We'll see. But anyway, it's some sort of remote connectivity. And they were able to cause a medication pump to deliver fatal amounts of an insulin dose from up to 300 feet away. So they were doing it nowhere near it anyway. And then a story about a cath lab in New Jersey had to shut down because their computer devices got all infected with malware, all of the devices they were using to do the cath procedures and stuff. So, yeah, it can happen.
Wasn't there a news story a while back about some type of maybe a heart transplant type device or something like that somebody had claimed that they could hack into?
Well, they always talked about how after Dick Cheney's well-publicized heart surgery, they always worried about having somebody around to check for, they were worried about somebody hacking into his pacemaker. Now,
just make sure your heart has antivirus.
Yeah, I know, really. And, but there's so much of this stuff that goes on. And so then this story really got my attention. And we briefly mentioned it in a previous episode. But what got my attention and sent me down this rabbit hole, medical devices, in July of last year, so it's just been a year, the Homeland Security and the FDA, because Food and Drug Administration deals with a lot of these medical devices, they warned hospitals not to use this specific Hospira Symbic infusion pump.
Good job.
I mean, we'll see how good that one is. An infusion pump, because of a security vulnerability that allows hackers to gain remote control of the system. Okay? So they're saying this thing has got a problem. And so, as reported, one would think, let's get rid of them. But the device manufacturer removed the hospital security protections that were in place to protect that device from internet access. They wanted to get to it remotely. So here is one of our big problems with this, the manufacturers, right? Because they're the ones supporting these devices and they want it convenient for them. Clearly, they're not thinking about this a lot because they removed it. And according to this CIO, it took 30 seconds for the unprotected device to get infected and transmit data over the internet.
Wow.
And the the OCR, I'm going down too many.
It was infected.
Just call them all. BIDMC said, the FDA said, DA. But the OCR said, it's the manufacturer that's responsible for the breach, not you guys, because they've removed what you had in place to protect it. So we've got multiple problems going on, creating very serious repercussions for failure. And you've got old software running on them, XP, and then you've got no endpoint security is what we call it. But, that means there's no, what's the best way to explain that?
Usually it's antivirus.
Yeah.
When we say endpoint, we mean the computer, the place that you're sitting there doing your work.
The place that got infected.
Yeah. It could be other devices, but typically it's wherever it ends.
Yeah.
Wherever the network ends.
Yeah, that node. So anyway, there was no security on those devices. Nobody's putting security on them because everybody thinks somebody else is working on them. Or the manufacturers don't worry about security, which is something that concerns me the most because I've talked with a lot of these people that are developing the things, and I'm like, you should be thinking about security first.
Yeah.
Not at the end.
It's like the app developers we saw at that conference, and we asked them about security and HIPAA, and they're like, nah, we don't know anything about any of that.
Yeah, but we aspire to be healthcare app and device builders. How about we start by saying, how can we secure this before we think it's a really cool thing to do? Oh, my God. But you hear these stories, and so people will say, and I had somebody telling me the other day about how there's a client that has this XP machine in place, and the XP machine is there because it's the only thing that'll work with this one X-ray report thing that they need to read. And to replace it, it costs $20,000.
Yeah.
Because you can't just upgrade that device and be able to talk to the machine they have. You've got to have a whole bunch of extra stuff. So the manufacturers are not making this easy, in my opinion. I don't know about yours.
I concur.
And so older devices, you got to come up, they make you just replace the whole device. They don't find a way to make the device move forward.
Mm-hmm.
And why does XP matter? We've talked about this. We've talked about it. So
talk about
2
it again.
years. Talk about it again.
Well,
didn't you? You told me this week you were going to say we're not doing any XP, didn't you?
Yeah, I've decided within my IT company that we're not going to support XP devices at all. Now, having said that, we do have some clients that are non-medical that have some, and we do what we call best case or best effort. So we'll try to do certain things on it, but we're not going to go too far with it because there's nothing you can do much with it anymore. If your software doesn't work on it, we're not going to spend time trying to get your software to work. Right. It's probably because it's outdated and it can't be updated. That's probably why it doesn't work. So we're not going to waste time on it. But yeah, most of it's the fact that it can't be updated. It's a huge security issue. And if it's in medical, it shouldn't be unless for some reason your risk analysis shows that device does not connect to anything else and it's not a security problem.
And you can claim that a lot, but you should be able to prove it.
Yeah.
But I mean, it's 2 years. Because I went back and looked and I wrote a couple of articles on the blog about, XP 2 years ago. It's going to end. And so that's March in 2014. I'm like, hey, now, you should worry about this and get it fixed. Mm-hmm. And then December 2014, there was a resolution agreement that specifically mentioned a couple of things, and one was that outdated operating systems, outdated software that was not maintained caused the breach.
Yeah, well, you probably remember too, especially like on LinkedIn and things like that, there were all kind of arguments about was using XP a risk or was it a breach just by having it? And of course, people argue both ways on that no, it's not a problem. You can still use it. And, it's kind of the same thing as the encryption software, TrueCrypt, that everybody was using that they came out and said, no, we're not going to support that anymore. Yeah. And it's not secure and people are still using it.
Yeah, because I'm not going to find anything else. So, and I that debate for me is, just having it on the system. Well, we'll get to that in just a minute about what we learned about how these things can be used against you, but it's very interesting. One other thing I wanted to point out, which is just a side note on that resolution agreement that talked about unpatched software being the cause of the breach, they were also dinged, we'll say, as far as the reasons that they had fines and penalties that they were facing was that they had used, the term was sample policies and procedures, which we know is templates.
A template, yeah.
And they had never followed them. So they had downloaded the templates and they were not following the policies and procedures. That's what we were ranting about on our policies and procedures episode. So.
Mm-hmm. Yeah.
But it's not just XP we're talking about. Unpatched Windows 7 is just as bad.
Unpatched anything, I would think.
Yeah, it could be. It just depends on how, is it brand new unpatched or... but a Windows 7 machine sitting there today that hadn't been patched is as bad as an XP machine with the latest updates.
Yeah, because 7's been out a while. So if you figure if it's never been patched, that's what, 3 years worth of vulnerabilities and security threats?
Well, even if it's just been like a year since it was patched, you know how many of those come out. So, but that's why we talk about these things. And then, so we go down that little rabbit hole and then we find this report. And first of all, it's a pretty badass company. TrapX.
Yeah. If you don't like him, they'll kill you.
I know. It's pretty intense what they do. And they've been able to get millions in venture firms funding and all of this. And two of the leaders are military folks. One's the Israeli Air Force and another is a U.S. Marine. So these people are not messing around. not somebody to mess with when you're good. Don't argue with them about security, please, kind of thing. And they have this anatomy of an attack series where they find these cyber attacks and they figure out everything that happened, and then they do a report on it so that the rest of us can understand, our mere mortal minds can understand. So they did the first one last year in May, and they came up with the term MedJack.
That's cool.
I know. Medical device hijacking, MedJack. And then they go with LoJack, though, MedJack. And so then they noticed not only is there MedJack, but also now, a year later, they found that there's a 2.0 version of it that's gotten even more vicious.
MedJack.2. They left off the O.
I know. .2. So, just Jack. But that's something showing your age right there. But the fact that the bad guys know that this is something they can do, and now they've made it even more useful to them and easier to hide away, is scary in itself. And they have 3 case studies that they used. So first of all, there's 3 that they could use that were people, they're clients of theirs. And they had a list of like 16 or 17 hospitals that were published, public information that had some sort of breach, kind of making their point. And I did like that HIPAA Journal called the exploits used in these attacks ancient.
Yeah.
In computer world, ancient.
That was last week then, right?
No, really? But in all these cases, the MedJack or the MedJack Point 2 was used to put in multiple backdoors and botnet connections, and the attackers were in complete control of these things. So it wasn't like, they had control of devices and equipment inside the network. That alone is terrifying. But so then is when we get to the scary part, that the malware, okay, you get to say this one, the malware propagated.
It does. That's what it does.
It propagates, but it wasn't detected by the security.
So it was a worm.
But everybody thinks that their antivirus, the endpoint security, and those things are going to detect those things.
Not only that, but the report even said that the hospital had a very well-funded, robust cybersecurity program.
Yeah, it's not like these were, willful neglect cases. Yeah. So I know there's going to be people like, if they can't stop it, I'm not even going to try. But that also does not fix the problem or protect anybody. It just
my neighbor got broken into, so I just leave my door unlocked.
I know. I know people, they get broken into and they add security alarms and make a steel door and all this. So think of that. You're right. Good point. Leave my door unlocked.
Yeah. Can't stop them while I lock the door.
So the bad guys have found ways to exploit a problem that has been out there since 2008. Everybody knows about it. But these devices are not being maintained. They're not being secured. IT doesn't get to work on them. But the device people aren't doing too much to protect them either. So everybody thinks somebody else should be handling it. Mm-hmm. And so this thing comes in using this other exploit. And because all the other computers have been, that has been closed up for a long time, that particular hole, if you will, it never goes through the other computers because it goes over and the other computer goes, no, thank you. I'm not interested in what you have to sell. So it keeps moving. And that way, for that reason, that endpoint security won't even see it because the computer knows not even to let it in that far. So, so what does the worm do? The worm keeps it propagates. The worm keeps propagating it. And so the worm keeps moving its way around throughout the network until it finds someplace it can get in. And it's like everybody talks about, well, every time I do something better and I close that down, they're going to find a new hole. They're not finding something new. They're going back and using old stuff.
Yeah, I know.
It's not like they've really found something new. But, the quote from this report that I pulled apart there is, you will see from these case studies that the malware was able to gain a foothold within the older operating systems in the medical devices and avoid any detection in the standard IT endpoints or network solutions. It enabled the attacker to install a backdoor within the enterprise from which they could launch their campaign and quietly exfiltrate data and perhaps cause significant damage using a ransomware attack.
Nice.
Wow. That's all I can say is wow. And the way they found these. Now, their TrapX software is really cool because it did find, so this has been going on for a while. No, none of the other tools are finding it. And in one case, it found it within an hour. And the other two, it found it within a couple of days, but it'd been going on for a while.
That's because they had a honeypot.
I know. I love the way theirs works. They put things out there that look like targets. So they make these little honeypots. You're right. It's not a term everybody knows. But so they make something look, they're trying to catch flies. So it's a honeypot. And so they make it look like something they want to attack. And the thing lets them in, but now the thing starts following them and they don't know it. So they call it, what do they call their deception technology is what TrapX calls it. So deception technology allowed them to catch it. But the bottom line is the attackers, they know healthcare is totally vulnerable. And they even made the point of saying that they're highly vulnerable due to medical devices and hence offer attractive, quote, low-hanging fruit.
We heard that one somewhere before.
Yeah, where does your fruit hang? So we did a whole episode about what happens if you have low-hanging fruit.
Mm-hmm.
So, but the stories were pretty interesting stories, though. How they got in and what they got to. And, so the first one, see, and I think this meant that, so there were 4 different vendors. So we're not talking like there's one key problem vendor. And the vendors, they made a point of saying it's not because these vendors are problems. These vendors are some of the most popular vendors in the industry. They use their equipment's used in a lot of places. So you've got in one hospital, you got vendor A and vendor B. I'm glad they didn't give names. That's probably something they decided not to risk. But they had a radiation oncology system and then this other LINAC gating system. I had to go look it up. It's a really cool thing that allows them to shoot radiation at moving organs like your heart and your lungs because they move. It's freaky. And then fluoroscopy radiology. So you see there's a theme there.
Yeah.
And all of those devices, all 3 of them, were managed by XP workstations.
Oh, wow.
Yeah. So the attacker comes in, hits the honeypot eventually, and then they trace them where they're going and what they're doing throughout the network from the honeypot, and they find that there's a back door and everything's headed out this back door. And back door to me sounds self-explanatory, but what does a back door really mean, David?
That means that's the place where you sneak in and out of.
No. Yeah. Think about we always use that thing. You got a store and then all of a sudden there's a back door that's standing wide open and you didn't even know the back door was there.
Mm-hmm.
That's what it is. It's just standing wide open.
Well, everybody pays attention. Well, everybody pays attention. I guess, go along with this analogy. Everybody pays attention to the front door. Everybody pays attention to the windows. Mm-hmm. No pun intended. But they don't pay attention to the back door. And so that's.
Well, and they put the back doors there that you don't even know there's a door there. Mm-hmm. It's hidden away. So they found each of those functioning as a back door, and the attackers, and I don't know if it was even a single attacker. It could have been multiple ones. I don't know. But they were then, from those workstations, able to worm their way through the whole network and exfiltrate data out that back door where nothing's watching. Mm-hmm. Ain't nobody looking.
If you don't see it, it doesn't happen.
Yeah. Yeah. So it took a couple of days, but it did pick up this traffic, and they followed it, and they were able to shut it down and block it off. But they did, learn a lot about how it got in. And in every case on this particular one, it was using those exploits to get through all of the other security that would then let them get into the XP workstations. So, and so when we're talking about how expensive those things are to upgrade, I'm assuming the one that I was talking about was just in the office. So these things that are really complex, I can't imagine what they cost.
Now, I think it might have been the first case, but and you correct me if I'm wrong, but one of those even had the risk analysis done. And I mean, they were on top of it. They were doing compliance really well. And part of the risk analysis, because they had pen testers come in doing penetration testing, and they said that part of the problem is these medical devices, and that needs to be looked at, which I guess nobody ever did.
Yeah, so these guys were doing everything right, but because the medical devices aren't controlled by IT, really, that's where it goes into a hole. It just drops into that never land, and that no one notices.
I imagine these vendors, they quote unquote support the device, and that probably means they just make sure it works and does what it's built to do, but they probably don't support the security and all that aspects of it. I mean, I don't know that, but I'm just kind of assuming.
Well, I think these cases will finally show that, the device just hanging out there on the network is enough to open up the entire network security. No matter how much security I do, if I have to use your device, you're leaving me wide open. Mm-hmm. And, so I don't know that it's going to change anything, but it's clear that that's the case.
At least we can have a conversation about it.
I know, really.
The more
somebody should look at it.
The more you know. Include it in your risk analysis.
So, and then in the second case, now this one was really interesting to me, because I'm like, so this is vendor C. So we got another vendor here, and it involves a PAC system. And a PAC system in the hospital, basically they take all these images that are being created from all these different devices, like x-rays and MRIs and, a lot of things create images in the hospital. And there's a standard that they follow. And this PAC system then can view all of those standard images. So you're able to pull them up and look at them. And is so clearly very valuable, right? Mm-hmm. And they let you track them and assign them. And so they do some cool stuff. And pretty much everybody has some sort of PAC system anymore. But this particular attack was through the MRI device itself. Yeah. So the device, not a workstation connected to the device, but the device was utilized. And here's the really bad thing. The only way that they could clean that thing up was to ship it back to the manufacturer. So
maybe it had an embedded OS or something?
Well, we did that when we were talking about the Internet of Things and how things get in there. Mm-hmm. So, who knows? There was no detail supplied on what the manufacturer actually found, but the vulnerability that it was able to utilize on that device led it into the whole PAC system.
Wow.
Because it was able to send in, little niblets, little breadcrumbs of digital dust that kind of let it follow its way in. And then it was able to take over those systems and do whatever they wanted.
So they could change the images out. If somebody pulled up your X-rays, they'd see like a image of Snoopy on a doghouse.
Yeah, I know. Really.
Yeah, you got some problems.
We need to see. What did you say you ate last night?
That would be kind of funny, though.
Yeah.
They put like a little ultrasound image of like an alien baby.
Oh, no. Those big piranha head or something.
See, we get some news coverage on that one.
Yeah. So in those devices, if you've got to ship it back to the manufacturer to get it cleaned, what can we do?
Nothing. Make a phone call.
Nothing,
Make a phone call.
No. So we as IT people, our hands are getting tied because people say, well, we got to use the XP and we have to use these devices because they're providing care of these devices. Don't forget that, patient care is supposed to come first. So, it would be very hard for me to figure out what's the right answer there. Because, of course, once you're using these devices, I also need to get the information from those devices into the other systems because everything is integrated. And that's the whole point of the digital world that we're trying to develop in healthcare is to make it more, friendly to each other so that all the systems talk to each other. And if they don't talk to each other, we're in trouble. So then we get to number 3. Hospital number 3, vendor D. Number 3 had D.
All right.
This is an old C-arm X-ray machine that is, near and dear to my heart. I've had to be called in before and try to make one of those, pull data off one of those before when it had a VHS tape. Now, this was a long time ago. So
do we need to talk about what that
we
is?
didn't know what we know now.
Do we need to talk about what a VHS tape is?
Really? They were like, this is what we used to put them on. So the scary thing that they found in here is a similar case of this X-ray machine. This C-arm X-ray was infiltrated. It was exploits that were utilized because, and we're going to have to explain what this is too, I'm sure. But because the device was running a version of Windows NT 4.0.
Wow.
I know. So that goes so far back. There are people working in IT that have never seen it. And this is stuff that happened recently. So Windows NT, let's see. So we got Windows 7. Before that was Windows XP. Before that was Windows ME. Before that was Windows 98 and 95. And Windows NT ran parallel as the business operating system to 95, 98, all the way up. And then I think it wasn't until Windows 7 that they merged, was it?
Yeah, but Windows 2000 took the place of NT4.
Oh, yeah.
Around,
they did. That's even worse.
Which was around 98-ish. I think around 98 is when 2000 came out.
Yeah. Yeah, so Windows 2000 and then the consumer and business Windows merged and they just had professional versions and home versions. But, oh my God, yeah. So Windows NT 4.0 makes Windows XP look like a young child running around on your network. So, I mean, to even know so if you've got these older devices and it's clearly working and doing a job, but that it had Windows NT on it, there was no way that anybody found that. And so you got to look at, you and I are big fans of a lot of these tools that'll go out and probe and scan the network. And I know these companies did this. You're talking about the penetration test. They're scanning the network. So these devices aren't configured to answer those questions.
So depending on what version you were using, it looks like NT stopped supporting their product around 97.
Oh my God. Windows NT 4.0. So, yeah. Well, the good news is the device is still working. The bad news is the device is still working. So it's absolutely an area that needs to be addressed. And everybody's really worried about, the FDA needs to be looking into these new devices that are coming out because they're gathering so much information. But all of these were older devices, clearly.
Mm-hmm. Oh, yeah.
So, what are you going to do about them?
Well, I think it goes back to what you were saying earlier. When you have certain things that you're running, software or hardware, unless you're going to update that, and it's a super expensive thing to do. We're talking in hospitals, but I mean, I know of small one provider clinics and practices where, you got a little ultrasound machine that basically plugs into an old antiquated laptop running XP. And in order for you to get a new device, you've got to spend $20,000, $30,000, $40,000 for this new device and new software. And because they won't sell you just the software, they won't even sell you the device. You have to buy everything as a kit. And they're just basically giving you a $600 laptop. And, but it's crazy. I've had to fix those things and find parts off of eBay and everywhere else trying to keep these things running because the doctor can't put $30,000 into another ultrasound machine.
But they need the ultrasound machine to treat their patients. And by the way, when we do that ultrasound, we're going to get less and less money for actually performing the task. Mm-hmm. So all the price is going up, but we're, it's a really complex system because everybody talks about, that our system of healthcare is like our rest of our economic structure of the capitalism, all this. But no other business that I know of has somebody else tell you what your prices are going to be.
Mm-hmm.
And if you try to charge more, they say, no, you're not allowed. And so it's complicated. And I know from the physician standpoint, which is where you and I spend all of our time, they're struggling with what to do. And if these are hospitals, and I actually had somebody tell me the other day, so-and-so worked here and they were spending money at a practice like they work for a hospital.
Yeah.
And I don't think I'll ever forget that. But so to say that these devices are something, you just replace them, that you can't. So the vendors have got to participate somehow in solving this problem because they've created it, But, they sold the equipment and, they have not given an easy way to solve the security issue. And then you got to wonder, well, what's the HIPAA compliance requirements of these vendors? Because they claim incidental exposure.
Makes it a little bit harder.
So there's the rabbit hole. We did pretty good. We didn't know how long that one would take.
Yeah. That's it's a lot to think about. At least now you know.
Well, yeah, that NT 4.0, terrifying. Mm-hmm. Uh-huh.
Yeah. That's good. Very good stuff. So everybody get off the podcast, go look for all your medical devices in your practice. Oh,
if they have a connection to anything, then they could be a potential problem.
Yeah. Well, the next stage in this, and we've talked about it in the Internet of Things, is that you really start finding out that it's the smartphones and the smart watches and all these other smart things. That's going to be the next thing that's becomes the issue.
Oh yeah, now you're getting outside of HIPAA necessarily. If I, as a consumer, elect to download and utilize an app that's going to capture all this information about me, and then I'm going to share it with my doctor, until I give it to my doctor, the doctor's not responsible for it.
Mm-hmm.
And because I'm buying it as a consumer, then the vendor isn't responsible for HIPAA either. But if you do it a different way where the doctor prescribes it, now the vendor, you're starting to get into a whole new ball of wax. But it's going to be interesting to see what people do when they start to realize just how much these wearables are going to do to you.
Yeah.
As well as for you.
So we could probably boil today's episode all the way down to this one thing, which is no matter how good your security is, no matter how good you're doing everything, you're still only as good as your weakest link. But you have to figure out what that is.
Somebody should look at that.
Yep. So anyway, that's our show for today. So we thank you for listening. If you enjoyed today's show, review it on iTunes like many others before you. Share us out on social media to all your friends, family, relatives. Even if you don't like them, share it. It doesn't matter. We'll take it all. You can visit us on our website at helpmewithhipaa.com. Hey, we also have a new thing. It's called push notifications. If you go to our website, you can sign up. I guess you say sign up. It's not really signing up. You just click on a button at the top. You should see this thing that says, hey, if you want to be notified of stuff, then just click here and click allow. We don't ask for your name, email address, or anything. And then we can send notifications to whatever device that you allowed us on. So when there are new episodes and things like that, we can let you know that. So check that out. And anything else, Donna, before we close?
No, I've got to find my way out of this dark hole.
I know, you drug me way down a rabbit hole today.
I don't need to add anything else. I need to get out and enjoy the day. I've just got to find a way there.
Yeah. All right. Very good. So until next week, remember, HIPAA is not about compliance. It's about patient care.
You've been listening to the Help Me with HIPAA podcast, hosted by Donna Grindle and David Sims. The show created to help you with HIPAA. For more information or to ask us a question, visit our website at helpmewithhipaa.com. Neither Donna Grindle or David Sims are attorneys, and they do not offer binding legal advice concerning regulatory compliance. The information in this podcast should not be relied upon or construed as legal advice in any way. Consult your attorney for legal advice concerning compliance with HIPAA regulations.